Hey there, and welcome. You know that feeling when you write a line of code, you expect one result from a simple calculation, but then you get something totally different? Well, today, we're pulling back the curtain on Java's hidden rules to see exactly how your code really thinks when it's doing math. Let's dive in.
All right, let's kick things off with a little puzzle. Take a look at this line of code. What's your gut reaction here? Do you see that 10 times 2 and want to do that first, which would give you a final answer of 5? Or do you just work from left to right and get 20? Well, one of those is right, and by the end of this, you're going to know exactly which one and, more importantly, why.
So here's the game plan. We're going to start with how we even talk to our program in the first place. Then we'll look at the tools we use for calculations, which are called operators. After that, we get to the good stuff, the two hidden rules, precedence and associativity, that control everything. And finally, we'll tie it all back to the math you already know. Okay, so before your program can crunch any numbers, it usually needs some info from you, the user. You can think of this as literally starting a conversation with your code. So in Java, our go-to tool for this conversation is something called the scanner class. It's basically a built-in tool that, you guessed it, scans for input. It's how we give our program ears, so to speak, so it can listen to what we're typing. And this is how you flip the switch. With just this one line of code, you create a new scanner and you tell it to listen to system.in, which is just a fancy way of saying your keyboard. And just like that, the line is open. Now what's cool is that your program can be a very specific listener. It doesn't just hear noise. If you need a whole number, an integer, you tell it to use next integer. Need a full sentence? Next line has got you covered. Each of these methods is like a specialized command to grab the exact kind of data you're looking for. All right, so we've got the data. Now what? We need to do something with it. That's where operators come in. I like to think of them as the action words, the verbs of your code. They make things happen. So what is an operator, really? It's just a special symbol that tells the computer to perform a specific job. You already know the most common ones, like the plus sign for adding things together, or the minus sign for subtracting. They're the basic building blocks for any kind of calculation. And it turns out there are whole families of these things. But for what we're talking about today, we really only need to care about a couple of them. The ones that do the math and the ones that make comparisons. Okay, first up, the arithmetic operators. You know these guys. They're the workhorses for pretty much any calculation. The only one here that might look a little funky is the modulus operator, that percent sign. All it does is give you the remainder of a division. Super handy, actually. Next up, we've got the relational operators. And their job is dead simple. They compare two things. They ask questions like, hey, is A equal to B? Or is A greater than B? And the answer they give back is always just a simple true or false. This is literally how your code starts making decisions. Okay, so we've got our data, we've got our operators. Now for the main event. When you jam a bunch of them into one line of code, how in the world does Java decide which one to handle first? This is where our first hidden rule makes its grand entrance. So check this out. Your brain might immediately go, okay, 10 plus 5 is 15, times 2 is 30. Easy. But run this in Java, and you get 20. Why? And that's not a bug. It's a feature. It's a rule. Java has a built-in pecking order, and it clearly decided that multiplication was more important than addition here. And that pecking order, that priority system, has a name: precedence. Just think of it like a ranked list for every operator. Some operators are just VIPs, and they get to cut to the front of the line. They always get to go first. And this, well, this is the official rule book. Whoa, okay, don't panic. You do not need to memorize this whole thing. Just zoom in on this part with me. See how the multiplicative operators, multiply, divide, are at level 3? And see how the additive ones, plus, minus, are down at level 4? With precedence, the lower number wins. It has higher priority. And that, right there, is why multiplication happens before addition every single time.
Okay, so precedence is great when you have operators with different ranks. But what happens when they're tied? What happens when they have the same priority? How does Java break the tie?
And this, my friends, brings us right back to where we started. In our little puzzle, 100 divided by 10 times 2, division and multiplication are on the same level in that chart. They're equals. So, who goes first? Does Java work from the left or from the right? The tiebreaker is our second hidden rule, and it's called associativity. All it is a simple direction rule. And for most operators in Java, including all the math ones we care about, the rule is left to right. Simple as that. When in doubt, when there's a tie, you just start at the left and work your way across.
And here's the proof in the pudding. Following that left-to-right rule, Java does 100 divided by 10 first. That gives you 10. Then it takes that 10 and multiplies it by 2, and voila, you get 20, the right answer. Now just imagine if the rule was right to left. It would do 10 times 2 first, getting 20. Then 100 divided by 20 is 5. See that? A totally different answer. This rule isn't just for fun, it's what makes our code predictable.
Now, if all this talk about order of operations is giving you flashbacks to middle school math class, well, it should. Let's connect what we just learned to something you've probably seen before.
A lot of us learned something like BODMAS or PEMDAS, right? Brackets, orders, division, multiplication. Well, think of Java's system as BODMAS on steroids. It has the same basic idea for sure, multiplication before addition, but Java's system is way more thorough. It's not just a memory trick, it's a full-on table that ranks every operator. And crucially, it has that explicit tiebreaker rule, associativity, which BODMAS kind of just assumes you know.
So here's the big takeaway from all this. These rules, precedence and associativity, they aren't just random things to memorize for a test. They exist to get rid of any confusion, to make sure that your complex calculations give you the same predictable result every single time you run your program. There's this great quote from a computer science pioneer, Joseph Weizenbaum. The computer programmer is a creator of universes for which he alone is the lawgiver. It really hits home, right? When you're coding, you're building your own little universe. And when you understand these fundamental rules, you're the one in charge. You're the one making the laws.
So now you get it. You know the hidden rules, the fundamental laws that govern how your code actually thinks. The logic isn't a mystery anymore. So I guess the only question left is, now that you know the rules, what universe are you going to build first?